Good morning, students. Myself, Vijay Shankar from EC Department, Civil Engineering College. Today, we are going to discuss about the continuation of the inverse transformation, the method partial fraction expansion method. Okay. And now you can find as a very important example, it having the two poles. And coming to this, it is a very important function. Z by the previous two examples, we have only the one pole and it gets in the 2 times or the 3 times. But here the 2 poles we have, one pole will get the 2 times and another pole will get the 3 times. Okay, what is the one pole here? The Z plus 1 is given. Z plus 1 is equal to 0. So Z is equal to minus 1. Minus 1 is a pole. And Z plus 2 is equal to 0. Z is equal to minus 2. Z is equal to minus 2. Z is equal to minus 1 will get it there 2 times because it having the power 2. And Z is equal to minus 2 is the 3 times it appears because it powers is a 3. And they're asking how to find out when the Z is greater than the 2 towards the right side, Z is less than towards the left side. And in between the 1 and 2 also you have to find out giving the ROC. With the ROC of Z is greater than, Z is less than, and in between of 1 and 2, have to find out the given x of Z inverse Z transformation x of n. Got it, my students? So using this Z is equal to minus 1 2 times and Z is equal to minus 2 3 times by using the residue method. By using the residue method, what is the residue method formula? 1 by k minus 1 factorial dou power k minus 1 dou z power k minus 1 whole multiply with z minus zi, that is zi is a poles, whole power k and x of z multiplying with z power n minus 1 at z is equal to zi. Using this relation, you have to find out the residue method for the given x of z to find the x of n. So first we have minus 1 with the 2 times and minus 2 with the 3 times means 2 residue methods will get. Z plus 1 whole square and Z plus 2 whole cube. The first part, if I am taking the first part, k minus 1, k value is there for the first part, k is equal to 2. K is equal to 2 and Zi is equal to 1, or the 1 minus 1. In this, k can substitute k minus 1 is a 2 minus 1 factorial. And k dou power 2 minus 1 dou z 2 minus 1 means the value is dou by dou z. And z minus zi is a 1, minus 1. So z plus 1 whole square, z by z plus 1 whole square, and z plus 2 whole cube, z power n minus 1 at z is equal to minus 1. So because it is the first derivative only, after cancelling the z plus 1 and the z plus 1 whole square, we have z power n, z plus 2 whole power cube. Now it is in the form of u by v rule. U by v rule. Take the v first of all, z plus 2 whole cube, and apply the derivative for the u, n into z power n minus 1 minus u into derivative of v. That is a 3 into z plus 2 whole power 3 minus 1. That is, students, so 3 minus 1 here is nothing but the 3 square, or the 3 square z plus 2 whole square. Got it? So I am taking here dou by dou z of z power n whole divided by z plus 2 whole cube. Okay. Now I am taking the first of all, it is a v, z plus 2 whole cube, and derivative of u, n into z power n minus 1 minus, taking the u, z power n, apply the derivative of this one, 3 into z plus 2 whole power square, whole divided by z plus 2 whole cube square, v square will get. Square means it is nothing but the 6. At z is equal to minus 1. What it matters, friends? Z is equal to minus 1. Now we can apply the minus 1 here. Apply the minus 1. So 2 minus 1 is a 1 cube. N into minus 1 whole power n minus 1 minus minus 1 whole power n, 3 into minus 1 plus 2, nothing but is a 1 square, whole divided by minus 1 plus 2, that is a 1 whole power 6. What is the remaining here? N into minus 1 whole power n minus 1 minus minus 1 whole power n into 3. 1 power 6, anything is a 1 only. But it matters, friends. Now we can rewrite this n into minus 1 whole power n and minus 1 whole power minus 1. Okay, bases are same, we can add the powers here. Minus 1 whole power n into 3. What it matters, students? So minus 1 whole power minus 1 is becomes of minus only. What it? Both the functions is a minus, that is equal to minus n into minus 1 whole power n minus minus 1 whole power n into 3. Take the minus 1 whole power n and the minus is a common. Minus n plus 3 minus 1 whole power n. Okay, that will get as a x1 of n because it is a first part. Part 1, we did the part 1 when the zi is equal to minus 1 and the k, it is a 2 times. So x1 of n is equal to, we got a minus of n plus 3 minus 1 whole power n. Let it be the equation 1. Now I am taking the second part using the residue method. What is the second part here? Z plus 2 whole cube and 2 into. See, using this formula here, minus 2 will get in the 3 times. Minus 2 will get in the 3 times. Okay. 3 times means now I can take this dou, not the dou, 1 by k minus 1. What is the k here? The 3. 3 minus 1 factorial and the dou 3 minus 1 by dou z 3 minus 1 will multiply with the, what is a z minus zi? Z minus zi is a z plus 2 whole power cube x of z. What is the x of z? Z by z plus 1 whole square and z plus 1, z plus 3, not the 3, z plus 2 whole cube, and it is multiplied with the z power n minus 1 at z is equal to minus 2. Okay, using this formula, by using the residue method, you can find out the x of n for the second part, x2 of n. 1 by 3 minus 1 means 1 by 2 factorial. And dou square by dou z square. And here z plus 2 whole cube and z plus 2 whole cube get cancelled. And the z and minus 1 is also get cancelled. Okay. And we have only the z power n by z plus 1 whole square at z is equal to minus 2. What it matters to us. Now you can apply this as 2 times partial differentiation. 1 by 2 factorial is nothing but the 1 by 2. I'm taking here u by v rule, dou by dou z of dou by dou z of gain. Take the first one is a z plus 1 whole square and apply the derivative for this one u n into z power n minus 1 minus take the v z power n u and 2 into z plus 1 whole power 1 whole divided by z plus 1 whole square, it becomes of z plus 1 whole power 4. Got it, my dear students? At z is equal to minus 2. At z is equal to minus 2. And again, you can simplify here. Inside, it is a simplified 1 by 2. Here, the dou by dou z is there. Dou by dou z. Take the z plus 1 and z plus 1 is a common here. In this, the z plus 1 whole power 4 is there. So it becomes of n into z power n minus 1 minus z power n into 2 whole divided by z plus 1 whole cube. Got it, my dear students? At z is equal to minus 2. So I take here the z plus 1. Here the z plus 1 is there, my dear student, because it is square is there. Z plus 1 is also there. Z plus 1 into n into z power n minus 1. Got it? So again, you can apply for this function. 1 by 2 into, as a 2 parts, dou by dou z of, I'm taking here. If this function, if I am taking, that it becomes of n into z power n minus 1 whole divided by z plus 1 whole square. The first part. The second part, the first one, minus, and here 2 into z power n only. 2 into z power n whole divided by z plus 1 whole cube. It is also dou by dou z, my dear students. Dou by dou z. At z is equal to minus 2 and both the functions. One is z power n minus 1 is already there. It is a z plus 1. It gets cancelled for z1 plus 1 whole square only. Z power n minus 1 by z plus 1 whole square and 2 into z power n by z plus 1 whole cube. Okay. So I'll take this function. I'm removing all these terms. See, first of all, if I am taking here dou by dou z of 1 by 2 already there. Dou by dou z of this function n into z plus 1 whole square, and for this function n minus 1 whole multiply with z power n minus 1 minus 1. Okay. According to the derivative of this, it decreases one value minus and z power n minus 1 and apply the derivative of this be 2 into z plus 1 power 1 whole divided by z plus 1 whole power 4. Got it, my dear students? This is the first part. I am taking the first part here. In this, you can substitute the value of z is equal to minus 2. If I am taking here itself, this 1 by 2 is both the functions. If I am substituting the z is equal to minus 2 here, minus 2. So what is value? Minus 2 plus 1. So 1 by 2 into n whole multiply with z minus z plus 1. Minus 2 plus 1 is a minus 1 whole square. N minus 1. And it becomes of minus 2 whole power n minus 2 minus minus 2 whole power n minus 1 2 into this becomes of minus 2 plus 1 is a minus 1 whole power 1 whole divided by minus 2 plus 1 minus 2 plus 1 minus 1 whole power 4. Okay, that is equal to, so leave it this 1 by 2 because it is a, both the terms is multiplied. Now I am writing only the n into minus 1 whole square. It becomes of a even term, the value is a positive only. N minus 1 and minus 2 whole power n minus 2 is there here. It becomes of a minus 2 whole power n minus 1 and minus 2 whole power minus 1. If I am writing the two parts, and minus 1 whole power 1, the value is a minus, and here the minus is there, it becomes of the plus 2 into minus 2 whole power n minus 1. Got it, my dear students? In these two functions, we have minus 2 power n minus 1 is a common term, is there? Common term. Take that common term, minus 2 whole power n. Before that, it is a minus 2 whole power minus 1 is also there. So if I am writing here, it is a minus 2 whole power minus 1, and here the minus 2 whole power minus 1, it becomes of minus 2. Take here the minus 2 and removing here minus 1. Okay. And here also minus 2 whole power n, write as minus 2 whole power minus 1. I will take only the minus 2 whole power n is a common term. N into minus 2 whole power n is a common term. N minus 1 plus n minus 1, here the minus 2 whole power minus 2 means it becomes of 1 by minus 2 whole square. Nothing but it is a 1 by 4. Got it, my dear students? So 1 by 4 by, you can write as 1 by 4 is a 0.25. 0.25 is multiplied with the n minus 1. Because it is a minus 2 whole power minus 2. I write it is a minus 1 by minus 2 whole square and 1 by 4. Plus, I take only the minus 2 whole power n is a common term. It becomes of minus 2 whole power minus 1. So 1 by minus 2. That is becomes of 2 into minus 2 is get cancelled. And here the 2 is there and the minus 2 whole power n is becomes minus 2 whole power n. It takes the value is 1 by minus the 1 by minus 2. It becomes of minus 0.5. Minus 0.5. So erase this one and write it as a minus 0.5 and 2 into. Minus 0.5 into 2. It becomes of 2 into 0.5. Nothing but 1 by 2 is a 1. value is 1. Got it, my students? N into 2 power minus 2 whole power n 0.25 into n minus 1. And again here also we can simplify this function, simplify n into 0.25 minus 0.25 minus 1. It becomes of minus 1.25. That is equal to n into minus 2 whole power n. I will write here, my dear students, because the final step it is. I am not taking the 1 by 2 here. 1 by 2 keep it is a side. Only the inside function I got it is minus 2 whole power n minus 2 whole power n and n into inside it is a n minus 1.25 and minus. So I take that is as a 0.25 n minus 0.25 and minus 1. So minus 1.25. The final answer. Got it, my students? Now I will take the second function, dou by dou z of 2 into z power n by z plus 1 whole cube. Okay, it is multiplied with the first term is there 1 by 2 whole multiply. This is the first term. The first term, my dear students, here. And take the second term 2 into z power n by z plus 1 whole cube at z is equal to minus 2. Okay, I am doing this also. Now I am taking the second term 2 into already 1 by 2 is there. This 2 it get cancelled, it becomes of 1. Okay. So it is multiplied with the first term only 1 by 2. This 1 by 2, if I am taking only the 1 by 2 is multiplied with the first term. Now that 1 by 2 and 1 by 2 get cancelled, the dou by dou z of z power n whole divided by z plus 1 whole cube at z is equal to minus 2. So now we can apply the u by v rule. Take the z plus 1 whole cube and n into z power n minus 1 minus z power n and 3 into z plus 1 whole cube whole divided by z plus 1 whole power 6 at z is equal to minus 2. At z is equal to minus 2. Now I am substituting the z is equal to minus 2 in this equation. Minus 2 plus 1 is a minus 1 whole cube. N into minus 2 whole power n minus 1 minus minus 2 whole power n 3 minus 2 plus 1 whole cube, that is nothing but minus 1 whole cube, not the whole cube, my dear student. This is a square. This is a square only, square, and it is also the square, minus 1 whole square whole divided by minus 2 plus 1 whole power 6 is a minus 1 whole power 6. And it becomes of before that there is a minus is there, my dear students. For this function there is a minus is there. Total function is minus is multiplied. Minus 1 whole power 6 is becomes a positive value. Minus of minus 1 whole cube, it becomes of minus n into, I take here that minus 2 is a whole power n, minus 2 whole power minus 1, and minus 2 whole power n, and 3 into, this is a square, is a value, is a positive value only, the 3, and divide by 1. This minus, you can multiply the two functions, all it is a positive value it becomes. So take the common is a minus 2 whole power n as a common, and it having the n term is there, n minus 2 whole power n is becomes of n by minus 2 whole power minus 1. It becomes of 1 by 0.2, nothing but the 0.5, that too minus 0.5. And the minus into minus is becomes a plus. Minus 2 whole power is get the common, the 3. Now we can add this function to the first term. This is the second one we got, second term. Add these two. Okay. And we have 1 by 2 minus 2 whole power n into 0.25 n and minus 1.25 plus this function, because I take already the minus here, I can add the term. Okay, what is our term here? The minus 2 whole power n, and it is multiplied with 1 minus 1 by 2. 1 by 2 is nothing but the 0.5, my dear students. So I take here the minus 2 whole power minus 1 is equal to, so 1 by minus 2. 1 by minus 2 means a minus 0.5. It is not the divide by the 0.5. Okay. I erase this function. It's minus 0.5. Write this as minus n into 0.5. Got it? So n 3 minus, I am writing the 3 minus n into 0.5. Got it? Again, in these two functions also, minus 2 whole power n is a common term is there. That is equal to minus 2 whole power n, you can take as a common. Minus 2 whole power n is to take the common, and whole multiply with the, I'm taking the n inside the 0.25 n square. I'm multiplying this minus 1.25 n and plus, and whole divided by 2 also there here, 2 and 3 minus 0.5 n. 0.5 n. The term. Got it, my dear students? That is equal to. This is only the second part we are doing, my dear students. The second part only. So the first part is already we got, it is a minus of n plus 3 minus 1 whole power n. We already got it. And it is a minus 2 whole power. One thing, n square term is there. N square term 0.125 by 2. 0.125 by 2 is there. And it becomes of n square, and 1.25 by n. Not the by n, 1.25 n by 2 is there, that is also the half part, and it is a n value. Got it, my dear students? So that is equal to, we can take it as a minus 2 whole power n, minus 2 whole power n. What is a 0.25 divided by the 2, half part is 0.125. 0.125. You can add the 0.125 onto 5, it becomes of 0, and it is becomes of 1 and 0.25, the half. Now I am writing the 0.25 by 2 is a 0.125 n square. Got it? 1.25 by 2. 1.25 by 2 is a 2 times, and it is a 0.65. 0.65. 0.65 and the 0.5 here, because both are the negative values only. So 1.25 by 2. What is the value of 1.25 by 2? It becomes of 0.6 2 times, and another value is the 5. 2 4s, I think it is a 4. Okay, or in terms of, you can take it as a value is a 5, 0.5 and 0.65. 0.64, let it be taken, it is a 5. 0, let the 4, and it is becomes of 6 by 5, it is 1, and it becomes of 1.14. 1.14. Well, finally, we can write as a 1.25 exact value, and 0.5 here. Exactly, you can take it is 1.25 you get. So if I am taking 125, half value is 62.5. Exactly, if I am writing 0.625, and it is a 5.5, you can add 5, 2, and it is becomes of 1.125. You can write as a 1.2. Let be the what it matters, students. So this, if I am writing, is a point minus 1.25, or the 1.25 n, and the last value here we have only the 3 plus 3. What it? So this is a function what we have. Minus 2 whole power n, 0.25 n square, minus 1.25 n, 1.125, my students. It is not whatever we got, it is a 1.125. This is wrong here, we got. This is what we got, it is a 0.625 and the 0.5. What is the value? 5, 2, 1 and 1.2, 1.125. Okay. This is not the 1.25. Modify this 1.125 n. I also wrote here the wrong. Minus 1.125 n. This is the final answer we got, and you can add this function with the previously what we got. It is the first part, minus of n plus 3 minus 1 whole power n v of n. Got it? So these are two parts we got. Why I multiplied is a 1 for the first ROC, saying that greater than the 2 and less than the 1, less than the 1, less than the 1, x of n is equal to, you see, instead of mu of n, write this a mu of minus n minus 1, keep the minus in front. Mu of minus n minus 1, keep the minus in front, and mu of n minus 1, keep the minus is in front. Okay, both will get it is a 1 minus into minus is a plus here, and here the minus into minus, it is not the minus, it is the plus. The value is already we have is a plus, and inside there is a minus 2 whole power n. Modify this also. So first term is a plus and the second term is a minus. In between 1 less than the z and the less than the 2 means z is greater than the 1 and z is less than the 2. So greater than you can multiply with the mu of n without keeping the minus here. And a less than means before that you can keep the minus and becomes is a minus mu of minus n minus 1. Wherever the value is 1, write is a right hand side. Wherever the value is a 2 is there, you can write in the left hand side. Got it, my dear friends? See here, 1 with mu of n and 2 with mu of minus n minus 1. And here also within the bracket I wrote 1 with minus of mu of minus n minus 1 and 2 with minus of mu of minus n minus 1. And here within the bracket I wrote one first term is multiplied with the mu of n and second term is multiplied with the mu of n. Got it, my dear students? Is here the 1.125. 1.125 is a modified by 1.125, and this is also 1. Got it?